Hello everyone. In this video, I'm going to talk about Heron's formula. This formula is used to find the area of a triangle. So let's say there is a triangle like this. And three side lengths are A, B, and C. And the perimeter of this triangle is the sum of A, B, and C. And when this sum is divided by 2, it's the half of the perimeter. Let's say this half of the perimeter is S. And Heron's formula says that the area of this triangle is the square root of S times S minus A, S minus B, and S minus C. So we are subtracting side length from half of the perimeter and multiplying them. So let's see how this formula is derived. So let's say the height of the triangle is h. In this case, the area of the triangle is half of base times height. And if we say the angle between A and B is theta, by the definition of trigonometry, h is equal to A times sine theta. So if we replace h in the area formula with A times sine theta, the area is equal to 1/2 of A times B times sine theta. And let's make the squared form of this equation. That means A squared is 1/4 of A squared B squared and sine squared theta. And using Pythagorean trig identity, sine squared theta is equal to 1 minus cosine squared theta. And if we use sum and difference formula, 1 minus cosine squared theta is factored into 1 minus cosine theta times 1 plus cosine theta. And if we use law of cosines in this triangle, cosine theta is equal to A squared plus B squared minus C squared over 2AB. So we can substitute this expression for cosine theta with the parentheses. If we do that, first parenthesis is 1 minus A squared plus B squared minus C squared over 2AB times second parenthesis is A squared plus B squared minus C squared over 2AB. And we can simplify expression in each parenthesis. So the first parenthesis is 2ab minus a squared minus b squared plus c squared over 2ab times second parenthesis is 2ab plus a squared plus b squared minus c squared over 2ab. And we can cancel a squared and b squared. And we can multiply numbers in the denominator. So the denominator becomes 16. And we can use a perfect square in each parenthesis. If we do that, the first parenthesis is c squared minus a minus b perfect squared. And the second parenthesis becomes a plus b squared minus c squared. And once again, we can use sum and difference formula to factor each parenthesis. In such case, the first parenthesis becomes c minus a plus b times c plus a minus b. And the second parenthesis becomes a plus b minus c times a plus b plus c. And now we can distribute this denominator to each parenthesis. So each parenthesis has the denominator of 2 because 2 to the fourth power is equal to 16. And when we compare these parentheses to the half of the parameter, we can say that the last factor is equal to half of the parameter. And if we switch signs in each side length, the first factor is equal to s minus a, and the second factor is equal to s minus b, and third parenthesis is equal to s minus c. And finally, if we take the square root on each side, we can see that Heron's formula comes out. So one good thing about Heron's formula is that we can find the area of any triangle if we know the three-side length of it. That's it for this video, and thanks for watching.